Hey everybody, so in this video we're going to continue talking about solving radical equations, specifically square root equations, and we're going to focus on equations that have two square roots, okay, but unlike last time where we had one on either side, or we could simplify them together, that won't be the case for these examples. Okay, so let's look at some examples. Okay, so as we said last time, the first thing we want to do is isolate a radical. Now, if there's two radicals, we want to pick one to isolate. And I will tell you that it doesn't matter mathematically which one you pick. Okay, so let's go ahead and just isolate the first one, okay, by subtracting this one to the other side. Okay. Now we're going to go ahead and square both sides. Okay. I will remember, right? I'll ask you to remember, sorry, or remind you that like last time when you have two terms like this, you want to square them both by putting it in parentheses. Okay. Now over here, the square root and the square will cancel out. I'll get 3x plus 1. Okay, and over here I'm going to write out what it means to square something, right? Multiply it by itself. Okay. So over here I still have 3x plus 1. Okay, and over here I'm going to multiply. 6 times 6 is 36. Okay, 6 times negative square root of 9 minus x is negative 6 square root of 9 minus x. Here I will also get negative 6 square root of 9 minus x. Okay, and my last term that comes from multiplying these two together, okay, is going to be plus 9 minus x, right? You know that when you square a square root, you'll get the radicand, and that's exactly what's happening here. Okay, so now I'm going to simplify by combining my like terms. I'm going to start by combining my like terms over here. So I have 36 plus 9, which is 45. Okay, and I have minus x. And then these two are like terms. They have the same radical, exactly, right? They have the same index and they have the same radicand. So this is going to be minus 12 square root of 9 minus x. Okay, and now I'm going to move this stuff to the other side. Okay. All right. 1 minus 45 is 44. Oh, sorry, I'm going to add x to both sides. Okay. And then 1 minus 45 is negative 44. Okay. All right. And then I'm going to go ahead and finish isolating the square root, right? This I would consider part of simplifying the square when you've squared both sides. But now I can see that I still have a square root left. So I'm going to repeat those first two steps. I'm going to isolate the square root and then I'm going to square both sides. Okay, so I'm going to divide both sides by negative 12. Okay, and then I'm just going to reduce this fraction on the left side by dividing everything by 4. Okay, so I get x, you can't really see that, okay, x minus 11, right? I said I was dividing everything by 4 over negative 3, okay, equals square root of 9 minus x. And then I'm going to go ahead and square both sides. Okay. Now when I square x minus 11, I should get x squared minus 22x plus 121. Okay, and 3 squared is 9. Okay, over here, the square root and the square will cancel, and I'll just get 9 minus x. Okay, now if I'm going to solve this, I really want to get rid of this fraction, so I'm going to go ahead and multiply both sides by 9. Okay. All right, so that was the first steps, and then those first steps repeated. Isolate the radical, square it, isolate the radical again, and square it again. Okay, now I'm going to finish solving. This is a quadratic. I have x squared, so I'm going to move everything to one side and factor. Okay, so negative 22 plus 9 is negative 13. Okay, and 121 minus 81 is going to be 40. Okay, now I'm going to solve this by factoring. Okay, what multiplies to 40 and adds to negative 13? It should be negative 8 and negative 5. Okay, set each of my factors equal to 0. And I get my two solutions, x equals 8 and x equals 5. Okay, all right. So even though this is a very lengthy process, okay, we still have to check our answers to see if they're extraneous solutions. Okay, so remember, you check for extraneous solutions by plugging them into the original equation. So we'll check our first solution, x equals 8. Okay, so remember our very original equation was square root of 3x plus 1 plus the square root of 9 minus x equals 6. Okay, so we're going to check this. 3 times 8 plus 1 plus the square root of 9 minus 8. We want this to be 6. 3 times 8 is 24, plus 1 is 25. 9 minus 8 is 1. Okay, root 25 is 5. Root 1 is 1. 5 plus 1 is 6. That's true. Okay, so our first solution, x equals 8, is truly a solution to our equation. Okay, then let's look at our second solution, which was x equals 5. Okay, and we're going to plug that in. So square root of 3x plus 1 plus the square root of 9 minus x equals 6. Okay, 3 times 5 is 15, plus 1 is 16. 9 minus 5 is 4. Okay, root 16 is 4. Root 4 is 2. 4 plus 2 is 6. That's true. Okay, so that means this is also a solution to my equation. And this equation just has two solutions. Okay, that's totally fine. There's nothing wrong. We didn't make a mistake. Sometimes these equations have two solutions. Okay. All right, let's try another example of this. So in this example, you can see that one of my radicals is already isolated. So I am done with the first step and I am ready to isolate, or I'm ready to square both sides. Okay, so let's go ahead and do that. Okay, the most common mistake I see with these problems is that students don't square the entire expression here. They just square these two separately. That absolutely doesn't work. It will 100% give you the wrong answer. Okay? All right. So y plus 4 squared, or square root of y plus 4 squared, is just going to give you y plus 4. Okay, and then over here, we're actually going to write this out. So we'll do square root of y plus 20 minus 2 times itself. Okay. Now let's look at what I'm going to get. Okay. Now this is still going to be y plus 4. Okay. Now over here, root y plus 20 times root y plus 20 is root y plus 20 squared, which we know is y plus 20. Okay. Then here I'm going to get negative 2 root y plus 20. Here I will also get negative 2 root y plus 20. And then here negative 2 times negative 2 is positive 4. Okay. And I'm going to simplify this by combining my like terms. Okay, so over here I just have this y, and then I have 20 plus 4 is 24. Okay, and then I can combine these two like terms to give me negative 4 root y plus 20. Okay. And I'm going to even further combine like terms. So I'm going to subtract y from both sides. That actually gives me no y's. Okay. And then I'm going to subtract 24 from both sides. So that will give me negative 20 equals negative 4 square root of y plus 20. Okay. So now I'm going to divide both sides by negative 4. Okay. Because the reason that I did this is because I know now I still have a square root. I need to isolate that and then square both sides again. So I'll have 5 squared and square root of y plus 20 squared. Okay. 5 squared is 25. Square root of y plus 20 is y plus 20. Okay. Now the last thing I have to do to finish solving here is just subtract 20 from both sides. So that will give me 5 equals y. Okay. So for this example, we only have one candidate solution, but we still need to check it. Okay, so we're going to check y equals 5. Okay. Remember my original equation was square root of y plus 4 equals the square root of y plus 20 minus 2. Okay, so this is going to give me 5 plus 4 equals root 5 plus 20 minus 2. So root 9 equals root 25 minus 2. Root 9 is 3 equals 5 minus 2. That's true. Okay, so this is a real solution to this equation. Okay. All right. And we're going to do one more example of this process. Okay. Now, before I said it doesn't really matter which one you isolate, and mathematically that's true. They will both give you the same answer. Now, in terms of ease of computation, like how easy is it to actually do this, right? It's easier to isolate the more complicated root. Okay. Now, if you go back and look at the other two examples that we've done, you'll see that they're of similar level of complication, so it doesn't really matter. Okay, but in this one is a lot more complicated than this one, so it's going to be easier to isolate this. Okay, so I'm going to go ahead and subtract 4 root y from both sides. Okay. Now I'm going to square both sides. Oops, that's a minus. Okay. Now remember, on this side, we do get that the square root and the square cancel out, so we'll get 1 plus 16y. Okay, and over here we're actually going to write out what we're multiplying. Okay. Now we're going to go ahead and multiply this out. This side is already simplified. Okay, here I'll get 5 times 5, which is 25. 5 times negative 4 root y, which is negative 20 root y. Okay, here I get the same thing, negative 20 root y. Okay, and here for the last term, I'm going to get negative times negative, so plus 16 root y squared, which is, right, we know that this is really just y. Okay. All right, so let's simplify this. These two are like terms, so I'm going to get minus 40 root y. Okay, and like we said here, root y squared is just y. Okay, so now I'm going to move all of my terms to one side, right? I'm trying to isolate this square root. So I'm going to subtract 16y from both sides. That actually leaves me with 0. And then I'm going to subtract 25 from both sides. That leaves me with negative 24. Okay. All right. Now, we're going to divide both sides by negative 40 in an effort to isolate this square root of y. Okay. So I'd get 24 over 40 equals root y. Okay. And then I'm just going to reduce my fraction here. Okay. So they're both divisible by 8. That would give me 3/5 equals root y. Okay. Now that I have root y isolated again, I'm going to square both sides. 3/5 squared equals root y squared. Okay. Square this side, I get 9 over 5. Or I'm sorry, 9 over 25. Okay. And over here, I'm going to get just y. Okay. So this is my candidate solution, and I'm going to check it to make sure that it's not extraneous. Okay, so I'm checking my solution, 9 over 25. Okay, so I'm going to plug it into my original equation, which was 4 square root of y plus square root of 1 plus 16y. Oops, y is 9 over 25. Okay, equals 5. Okay, well, square root of 9 over 25 is 3/5. Okay, now we would have to do 16 times 9. So let's do 16 times 9 real quick on the calculator. And I get 144. Okay, so I'm going to be adding 1 to this. So this gives me 12 over 5. Okay, so this would be 25, right? 25 over 25 plus 144 over 25, okay, is 169 over 25. Okay, now square root of 169 is 13. Square root of 25 is 5. Okay, now these even have common denominators. We can just add them together. 25 over 5 equals 5. Well, that's true. Okay, so that means that this is really a solution to this equation. Okay. I really encourage you guys to practice these problems. They're not that much harder than the other style of problems that we did in the previous video. They just take getting used to. Okay, and I will see you guys soon.